Welcome, class, to the Intro to Java Programming. In this lesson, we will review the object-oriented programming principles, cover the 4 major building blocks, and show how they work together. Common and recommended uses will be highlighted that will point you in the right direction. Object-oriented programming is about creating objects that contain both data and methods. The 4 building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. Let's briefly cover the definition of each term. Encapsulation simply means binding object state, or properties, and behavior, methods, into a single unit to enforce modularity. If you are creating a class, you are doing encapsulation. Encapsulation also ensures that your data is hidden from external modification, also known as data hiding. Inheritance is the mechanism by which an object acquires some or all properties and methods of another object. It creates a parent-child relationship between 2 classes. Abstraction means using simple things to represent complex things. Abstraction is a process where you show only relevant data and hide unnecessary details of an object from the user. Polymorphism means existing in many forms. With the use of contracts, overloading, and overriding, we can enforce simplicity, which makes the code more extendable and easier to maintain. It lets programmers use the same word to mean different things in different contexts. One other term that falls between abstraction and polymorphism is the interface. An interface provides a mechanism that allows unrelated classes to implement the same set of methods. This is another form of abstraction meant to have a simple thing represent a complex thing. Yes, these definitions are a little vague until you better understand the true meaning. Encapsulation. If you're creating a class, you're doing encapsulation. Inside the class could be constructors, properties, and methods. The properties are the data fields and object state. The constructor and methods are the behavior. The contents of this class is a single unit with a single responsibility. Constructors, properties, and methods can be public or private. Expose these to other classes that need to know this information. Hide these from other classes that do not need to know the inner workings. This is data hiding. There are several rules you should follow. Here are a few important ones to remember. Coach Joe rule number 6 states a class should do only one thing. If a class performs more than one action, this is known as a side effect and could be misleading to other developers. Coach Joe rule number 7 states a method should do only one thing. A method should only perform one action. If a method performs more than one action, this is known as a side effect and could be misleading to other developers. And finally, Coach Joe rule number 34 states, understand the difference between a data object and a data structure. Episode 15 covers this topic in detail. Please review for more information. The purpose of a data structure is to organize data that can be passed around or managed as a single object with the use of properties and getters and setter methods. There should be few, if any, exposed methods. The purpose of an object with responsibilities is to perform some service, add behavior, or do something with the use of methods. There should be few, if any, exposed properties. Try to remember, a data structure has things, and an object does things. Inheritance is accomplished by taking 2 classes and connecting them together in a parent-child relationship. These 2 classes can be called the superclass and the subclass. The superclass is a class being inherited from. It is often referred to as the parent class or the base class. The subclass is the class that inherits from the superclass. It is often referred to as the child class or the derived class. Both classes should follow all the rules of encapsulation. The child class can access all the public constructors, properties, and methods of the parent class. The parent cannot access any constructor, property, or method of the child class. 3 different classes can be used to form a type of inheritance. A normal class that could contain constructors, properties, and methods, no abstract methods, an abstract class that could contain properties, methods, and abstract methods, and an interface that could contain only abstract methods. Abstraction is using simple things to represent complex things. My favorite example is the remote control for a television. The power on, power off button is simple to use. Behind the scenes, there's a complex communication process between the remote control and the television that turns the device on or off. How the remote control actually works is abstracted away or hidden. Simply clicking the button is the only thing you need to know. In episode 33, an example of an adventure game attack process was used to illustrate abstraction. The game control class will call an attack method. An abstract method for attack is inside an attack interface. The attack service implements the attack method and calls several private methods that perform the attack. Abstraction is accomplished when the game control class has no knowledge of the attack process. It only needs to make one simple method call. The attack process can be altered in the attack service without a code change in the game control class. Polymorphism means existing in many forms. Specifically, classes and methods can exist in many forms. Let's review the three different types of polymorphism: dynamic, static, and object reference. Dynamic polymorphism is achieved with method overriding. In a parent-child relationship, a child can override a parent method. Other classes that call the method will get the result from the child, not the parent. Static polymorphism is achieved with method overloading. Inside a class, two or more methods can have the same name as long as the method signature is different. Object reference polymorphism can be achieved with an abstract class or an interface. Let's say we have an interface called monster that is implemented by a goblin class and a skeleton class. Let's say there is a variable monster that is using the monster data type. Object reference polymorphism is accomplished by referring to the goblin class by using the monster class reference. This means monster equals new goblin will work, and monster equals new skeleton will work. Both classes are using the same object reference, the monster interface. This also means that a method that accepts a monster object reference will accept a goblin or a skeleton in the parameter. Understanding the object-oriented principles is one thing. Applying the principles inside a project is another and can be confusing. If your project has only one class, you will barely use the four principles. It is likely your project will have 5, 10, or more classes. These classes will need to work together. Using the four principles will help. Two classes need to interact with each other. The options are inheritance or composition. Inheritance is used to connect two classes together in a parent-child relationship. Composition is used when a class has a property or a variable with the data type of another class object. We have done both several times in prior lessons. Good question. When should you use inheritance and when should you use composition? Inheritance should be used when you have an is-a relationship. A goblin is a monster. Monster is a general, non-specific class. A goblin is a specific monster. Since there could be many different types of monsters, using inheritance or the is-a relationship makes sense. Like, a goblin is a monster, a skeleton is a monster, a dragon is a monster. Composition should be used when there is a has-a relationship. A goblin has a weapon. Inside the goblin class, there likely will be a property or a variable used to indicate the type of weapon used. Weapon could be another class. Since the goblin class can contain a weapon class object, this is composition. Like, goblin has a weapon, goblin has loot, goblin has armor. So how do you know which to use, inheritance or composition? One way is to use the two classes in a sentence and see if it makes sense. More times than not, it'll point you in the right direction. Monster is a goblin. Monster has a goblin. Goblin is a monster. Goblin has a monster. Goblin is a weapon. Goblin has a weapon. Another way to determine if inheritance should be used is if a class is a general class for other more specific classes. There can be many types of monsters like goblin, skeleton, and dragon. Use inheritance to connect monster and the type of monster. There are not many types of goblins, at least in this adventure game. Inheritance is not needed. There could be many types of weapons like sword, axe, and bow. Use inheritance to connect weapons and the type of weapon. Using the object-oriented principles will help two classes interact with each other. Use inheritance with abstraction. Use composition and polymorphism to access abstraction. Each situation is different, but here's a general summary that will help point you in the right direction. Encapsulation is something you will be doing all the time. If you are writing a class, you're doing encapsulation. Be sure to follow the rules of encapsulation. There are many rules, here are a few important ones. A class should do one thing. A method should do one thing. Know the difference between an object and a data structure. Expose methods and properties needed by other classes. Hide methods and properties from other classes that do not need to know the inner workings. This is data hiding. Inheritance is used to connect two classes together in a parent-child relationship. This is something you will be doing all the time. A parent can be a normal class, abstract class, or an interface. The normal class has all regular methods and no abstract methods. An interface has no regular methods and all abstract methods. The abstract class can contain both. When using inheritance, your goal should be 100% abstract methods in the parent class. The interface should be your first choice. Abstract class with many abstract methods and limited regular methods should be your next choice. Try to avoid making a normal class as your parent. Abstraction is something you should strive for in your design. It is possible to have a working program with no abstraction. With abstraction, your program will be more flexible, easier to maintain, and easier to read by other developers. Polymorphism is also something you should strive for in your design. Dynamic polymorphism or method overriding is frequently done during inheritance. Static polymorphism or method overloading is not frequently done, but very useful in certain situations. Constructor overloading is common. Object reference polymorphism should be frequently used during composition and abstraction. Try to remember, composition should be favored over inheritance. Use inheritance with abstraction. Use composition and polymorphism to access abstraction. Correct. The attack example used all four principles along with composition. Here is the final result of the game control class calling the attack method from the attack service. Encapsulation was used in the game control class, attack interface, and attack service. Each class is following the rules of encapsulation. It does one thing. Inheritance was used to connect the attack interface and the attack service together. Remember, the parent class should favor the interface over a normal class. Utilize abstract methods over non-abstract methods whenever possible. Composition was used inside the game control class to hold the attack interface as a variable. Abstraction was used to hide or abstract away the attack process from the game control class by calling a single abstract method. The attack service implemented the abstract method and performed all the work. Two forms of polymorphism were used. See if you can spot them. The attack service is overriding the abstract method from the attack interface, and object reference polymorphism was used in the game control class during composition. The attack interface was used as a variable. You should now have an understanding of the four object-oriented principles. Descriptions, examples, and recommended uses of each were provided. An attack example illustrated how all four principles can be used together. With review, study, and understanding of these principles, you will be building flexible, maintainable, and easy-to-read programs. This is the end of the Part 2 series. Look for the Part 3 series where we discuss more advanced topics and use the basic commands to build a few programs. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!